So today we're going to look at what happens when we have a mixture of series and parallel circuits together. And the most important thing is just that you remember that you're going to have to mix and match the rules that you learn. So on a series circuit, voltage is up. On a parallel circuit, the voltage is the same for both branches. So how can we solve those kind of problems? And what I found the easiest way to solve the problems is to take our parallel circuits and collapse them into series circuits, and then use our series circuit rules to figure out things like voltages and currents and stuff. So let's take a look at this example. I have three 8-ohm resistors. Whatever current is flowing through here, all of it flows through this resistor. But when it gets to this point, it splits and goes this way or this way. Now, since both of those resistors are the same, half of it will go one way and half will go the other. But if they're not the same, then it will go towards the lower resistor. All right. So how can I solve this if I want to get the total resistance of this circuit? Okay. I don't have any currents, I don't have any voltages, I just want to know what's the resistance of this circuit. The way I'm going to do that is I'm going to combine these two resistors into one. Okay, so I'm just going to pretend like this resistor doesn't exist and that resistor doesn't exist, and I'm going to say, let's combine it into one resistor, and what is the resistance of that resistor? 1 over the total resistance of this resistor is equal to 1 over 8 ohms plus 1 over 8 ohms, right? You guys remember that from your parallel. So that's the same as 2 over 8 ohms, isn't it? So I can just flip those. Okay? Now, if you were to put this into your calculator, what do you get? Because that's how most of you are going to do this. I know that. Okay? What you're going to do is you're going to plug in 1 over 8, and you're going to get 0.125 plus 0.125 equals 0.25. Then you go back and you go 1 over 0.25 equals 4. That's what your calculator will show. Right? If you pick up your calculator and you go 1 divided by 8 plus 1 divided by 8 equals 0.25. Now I go 1 divided by 0.25. If you're lucky and you have a calculator that has that little 1 over x button, you can just hit the 1 over x button, the reciprocal button, and it'll flip it for you. Okay? Anyway, and you get 4. All right. Let's look at something a little more complicated. Here, I have a 24-volt battery. I have 2 resistors in parallel with each other, and they are in series with 2 other resistors which are in parallel with each other. This is what your quiz will look like tomorrow. It'll only be 5 questions, but they're all going to look similar to this one. So how would I go about solving for this? Well, one of the first things I can do, if I can solve for the total resistance of the circuit, then I can get the current that's flowing through the circuit. That's at least one approach that I can do. So the first thing I'm going to do is I'm going to try and solve for the total resistance of this R1, R2 resistor. Okay? If I were to get rid of those and treat that as one resistor, I could figure out what the resistance of that is. Okay? That little group. So how can I do? So 1 over R1, comma 2 I just made the subscript so that I know what this is that I'm talking about, is going to be equal to 1 over 10 plus 1 over 40. Now you can plug this into your calculator if you want and get an answer. I usually, on things that are integers, it's often easy for me to find a common denominator so I can add these together. And the denominator is 40. So this is actually 4 over 40 plus 1 over 40, which is 5 over 40. So that means R12 is equal to 40 over 5, and 40 over 5 is 8 ohms. So this guy right here is 8 ohms. So this is 8 ohms, that combination of those two in parallel. So how about this guy? Well, I'll call this R34. One over R34 is equal to 130 plus 1 over 20. Can't add those up directly, so common denominator would be 60, right? So that'd be 2 over 60 plus 3 over 60, which would be 5 over 60. So R34 is equal to 60 over 5, which is 12 ohms. So this guy is equal to 12 ohms. You do that on your calculator. Or if you do it on your calculator, what do you get? You say 1 over R34 is equal to 1 over 30 plus 1 over 20. And what you end up with on your calculator is like 1 over 0. You end up with 0.0333 plus 0.05, which is equal to 0.0333. And then you do 1 over 0.0833, and you end up with something like 12.00004 or something, because you round it. All right? 12. Anyway, so these two are together become 12 ohms. So now I have two resistors that are in series. Essentially, I have built this circuit. I now have a 24-volt battery, and I have 8 ohms and 12 ohms. What's the total resistance of a series circuit? 8, 12. 8 plus 12 is what? 20. So the total resistance of this circuit is 20 ohms. Can I now solve for the current? How would I solve for the current? The total current is equal to the total voltage divided by the total resistance. So it's equal to 24 volts over 20 ohms, and that's going to be 1.2 amps. So there's 1.2 amps that flows in here, 1.2 amps. Some of it goes to the left and some of it goes to the right. But more goes to the left because it's lower resistance. Okay? That's the big pipe. The 40 is the small pipe, which has more resistance. So more of it goes this way, some of it goes this way. Then it comes back together again and it's 1.2 amps. Then it splits again. More of it goes to the right because it's lower resistance. And then it comes back together and it's 1.2 amps again. But we don't know how much goes to each side. to do that, we need to figure out the voltage drop across these. Now remember, the voltage drop in a series circuit, we can add together. The voltage drop in the 8 and in the 12 is going to have to come out to 24. All right? So let's figure out that. If the current going through 8 ohm resistor right here, the pretend 8 ohm resistor, and really we don't know what's inside a resistor anyway. It could be series, it could be parallel, it could be anything. It's a black box to us. I just converted it into an 8 ohm resistor, okay, so that I could do some math. But if it's an 8 ohm resistor, and I know that the current flowing through it is 1.2 amps, can I calculate the voltage? Can I calculate the voltage through an 8 ohm resistor if the current is 1.2 amps? This voltage up here is going to be my 1.2 amps times 8 ohms. And so that's going to be 9.6 volts. Now the voltage, when it splits here, is the same for both resistors. Remember that when you have circuits in parallel, the voltage drop across the resistors parallel is always the same, which means the voltage drop here is also 9.6 volts. The voltages have to be the same. Now let's look at the other one. We have 12 ohms and 1.2 amps. What is 12 times 1.2? What's 12 times 12? 144. So 12 times 1.2, 14.4. Ah, 14. Trying to do V and 4 at the same time. The voltage drop across these two has to be the same as it would be across the single resistor. Okay? We made a pretend resistor in the middle and said that's what it would be if these worked together. So the voltage drop across our made up resistor is the same as the voltage drop over the 30 and the 20 because they're in parallel. It's the same as a water pipe. Remember, I always talk about this similar to a water pipe. If I have a pump and a piece of pipe, and the pipe is going like this and it splits in two, I've got a small pipe and a big pipe. More current's going to go through the big pipe than the small pipe, right? But the pressure where the split happens, pressure is voltage, the pressure where the split happens is exactly the same. Okay, so the pressure is the same through the big pipe and the small pipe. But the volume of water that flows through is obviously going to be bigger through the big pipe. That's the current, right? So currents are different on these two pieces. But they add up to the current that's the same everywhere else in the pipe. Okay? All right. So now that I have voltages, and I have real resistances that I can look at here, I can get real currents. So let's do that after I get the cap. Okay. Try a different color too. Current is going to be equal to voltage divided by resistance. 9.6 divided by 10, even I can do that in my head, 0.96 amps. 9.6 divided by 40 to get the current here. I can sort of do that in my head because I know that it's going to be 1/4 of 96, so that's 0.24 amps. If I add these together, what do I get? What's that? 1.2. 1.2. 1.2. Because the whole current flowing through this circuit is 1.2 amps, it splits. Some goes to the left, some goes to the right. More goes to the left than to the right. 0.96 goes to the left, 0.24 goes to the right. But the whole current of 1.2 amps has to go somewhere, doesn't it? Yeah. Now it comes back together and it's 1.2 amps again, and then it splits. And let's see how that split works. 14.4 divided by 30. I can't do that one in my head. .48. And 14.4 divided by 20. I can actually do that one, but 0.72 amps. If I add those together, what do they equal? 1.2, right, they have to. And we can do the power. The power becomes trivial. It's just voltage times current. All right? So voltage 24 times 1.2 to get our total power. So 24 times 1.2, 28.8. And that should be the sum of all of the individual resistors' power as well. So we can do that if we want to go on and figure out the individual ones. 9.6 times 0.96, that is just a coincidence. 9.22, I rounded. .3. .9. And 10.4. Again, I did round these, but if we add them up, they should come out to 28.8. Okay? Very close. Everybody see what we did? Converted my parallel portions into a series circuit to get the voltage drops, and then I used those voltage drops for both resistors to get the current. So let's look at something a little more difficult. Well, no, it's not. It's actually easier. This one's easier because there's a lot of symmetry, meaning a lot of things that are the same on two sides. So you can use some shortcuts. All right. Let's look at this right here and combine this into a single resistor. These are in series with each other, aren't they? So these two together equal 20 ohms, don't they? I'm going to call this, we'll call this R1, R2, R3, R4, and R5. So these two together, 1 and 2, in series are 20 ohms. How about these two in parallel? Since they're identical, when you have two identical resistors in parallel, it only works with two that are identical. The resistance is 1/2 of whatever their resistance is. Anybody who's ever done audio stuff knows that two 8-ohm speakers in parallel make a 4-ohm speaker. So if you're into the big giant speakers from the 70s, 80s, and 90s, that's like walking around with your music plugged into your brain directly. Yeah, R3 and 4, or pardon me, 4 and 5, That's equal to 1 over 8 plus 1 over 8. So that's 2 over 8. That's 1 over that. So R45 is equal to 8 over 2, which is equal to 4 ohms. So these two together, 4 and 5, are equal to 4 ohms. But they're in series. So this guy right here, this 4 ohms, is in series with 16 ohms. So 16 and 4 is what? 20. Right. So all three of these together are 20 ohms. So now we have a circuit that looks like this. Let me do it in a different color here. Now we have this circuit, 60 volts. $20 ohms, 20 ohms. You all right there? You like what? So the resistance, I can calculate the resistance of this circuit, but and they're both the same in parallel. The total resistance is going to be 1/2. When I have two things that are identical, the overall resistance, 1 over 20 plus 1 over 20, that's 2 over 20. And when I flip it, 20 over 2 is 10. So the total resistance of the whole circuit is 10 ohms. So I can go on and here now, 10 ohms. And I could use that to calculate the current, because resistance, voltage divided by resistance is equal to the current. So the total current is 6 amps. Yeah, oh yeah. So 60 times 6 voltage times current is power. So 360 watts, I can calculate that as well. Did I?
Yeah. Because then you got 28.8.
Huh. Okay. So I must have made a mistake then. We'll go back and take a look at that in a minute. We're not actually going back, we're waiting. There we go. Okay. So, yeah, if I made a mistake, I apologize. Is equal to current times voltage. Current times voltage. We can go back and watch and see. All right, so anyway, so we've got this bottom line filled out, but now we've got a lot of symmetry we can work with. First of all, we know that the voltage drop here is 60 volts for both of these circuits. So at point here, it's 60 volts, and at this point, it's 60 volts. But we don't know the drop across these individual resistors. But we have some rules for that. And we also have some other things that we can use to solve for that. If the voltage drop across here is 60 volts, and each of these is the same, and the voltages add up, then really we could say that this one is 30 and this one is 30. Voltages add up. Okay? So we can look at that and say 30 volts and 30 volts. We can look at, if we want to solve that explicitly, and what we have to do is we have to say that the two of these voltages together add up to 60. Because voltage drop across this is 60 volts. And we know that the resistance is 20 ohms. So we can calculate the current. So if we have 60 volts and we have 20 ohms, what is 60 volts divided by 20 ohms? 3 amps. And we know that those two are the same. They have to be equal because that's a circuit, isn't it? 3 amps is flowing through here, so 3 amps must be flowing through as well. Now the total current is 6 amps. So if 3 amps is flowing this way, how much must be flowing this way? The other 3 amps. It all goes through the 16 ohm resistor. It has to. So to find the 16 ohm resistor, we can say that's 3 amps. But wait, it splits here. And some goes up here and some goes down there. How much? It should be half because those resistors are exactly the same. So it should be 1.5 and 1.5. Okay? So these two are the same. If we add this plus this, we should get 6. And we do. We can now go back and look at individual voltages if we want. 16 times 3 amps. So the voltage drop there is 36. 8 times 1.5, so the voltage drop there is 12. 8 times 1.5, so the voltage drop there is 12. These two are in parallel, so they have to be the same. Oh, wait, did I calculate voltage drop incorrectly there? I did, didn't I? I'm sorry. 16 times 3 is not 36. I did 12 times 3 in my head. 16 times 3 is 48. You guys need to check me on these things. All right, so if I add up 48 plus 12, I get 60. 30 plus 30 is 60. I can now go individually and look at the power. Again, that becomes trivial now that we've got all these other things done because it's always voltage times current. And they always add. They always add whether they're series or parallel. Because every little bit of power that's being used adds up to the total amount of power that's being used, wherever it's being used. So 30 times 3 is 90. 30 times 3 is 90. 48 times 3 is 100. And what is that, 144? 12 times 1.5 is 18. And 12 times 1.5 is 18. And if I add all that stuff up, that should add up to 360. I'll let you guys do that. Now, if you look at the website here, I will have the video of what we just did right here for the people who are absent for band. Underneath that is a video where we're working through a series of PowerPoint slides or Google slides. And originally, the slides that you can see off to the left here, these slides all came from this worksheet. Okay? Originally, this was for, during COVID, you did the work on the Google slide and submitted the Google slide. Okay? Because there was nobody here to give a worksheet to. So we did it all on Google slides. They are not in order. And the very first slide up there is not on this page, okay? But if you go through the video, it talks about at the beginning it talks about how to, and this was like just when COVID first came out. So some of this video is explaining how to like split your screen in half and how to watch on one side and fill in on the other and stuff like that. But if you scroll through the video, eventually you'll get to the problems. Now again, this first problem is not on the worksheet. It was a separate slide. But after you move on through the video and she explains how to do, after she gets done with that first slide, she goes on to a couple of the other slides and walks through how to solve those problems. All right, I think she does maybe only a couple of the slides, but she does walk through how to do them. So again, the first slide is not on there, but she does walk through this one. I'll tell you what, I'll walk through this one. Let's walk through this one. Okay, this is the second one on your paper. Yeah. Yeah, hurry. So let's walk through this one. We've got a 40 volt source, so we put that in. We have 3 ohm resistors. We don't know the total resistance, and we can't add them because these two are in parallel. These two are in parallel. So what do we know about parallel resistors when they're exactly the same? It's half, right. If there are 2 only, then we know that the total resistance R1 and R2 together are going to be equal to half of this. So this is 15 ohms. Okay? So 15 ohms, we now have a circuit that looks like this. So we have a 15 ohm resistor and a 5 ohm resistor. And they're in series. So now we can add those together and we get 20 ohms. So now we know that the total resistance is 20 ohms. We also now can solve for the current. If we have 40 volts and 20 ohms, the current is voltage divided by resistance. 40 by 20 is 2 amps. We have 2 amps of current flowing through R3. It all has to go through R3. Can everybody see that? There are no other branches. It has to go through R3. So we know that the current through R3 here is also 2 amps. And if we know that, we know the voltage. 5 times 2 is 10 volts. Now by subtraction, we can actually get the voltage drop across this. Okay? Because we know that 40 volts minus 10 volts is 30 volts, right. So the total here must be 30 volts. Okay, and since these two are in parallel with each other, the voltage drop is the same. The voltage drop is the same. Now, another way we could have solved for that. Sure. Remember that we converted this into a 15 ohm resistor, right? And through that 15 ohm resistor, we know that current is equal to the voltage divided by the resistance. So it's equal to 40 volts divided by 15 ohms. Wait a minute. No. What am I saying? Voltage is equal to current times resistance. And we know that the current is 2 amps. And we know that the resistance is 30 volts. So we know that the voltage, boy, I am really not with it today. Hold on. Times 15 ohms. I'm getting way ahead of myself. 30 volts. Sorry. It's what happens when I'm planning the next thing I'm going to say. before, and I write down what I'm planning to say next. Okay, so I could have calculated the 30 here because I know that the current flowing through both halves is 2 amps. And I know if 2 amps of current is flowing through there,
Thank you so much.
and the resistance is 15, then the voltage drop must be 30. Now I can solve for the individual currents through these two, and that actually is pretty simple since they're both identical. Half must go one way and half must go the other. So half of 2 is 1. I can also do it by math. 30 volts divided by 30 ohms is 1 amp. 30 volts divided by 30 ohms is 1 amp. Okay? If these had been different, that's what I'd have to do. Everybody get it? Okay. So between this one and the other one that my wife does, which is on the sheet as well, so she does one that's not on the sheet, then she does number 1, and then I did number 2 just now. So you guys should be able to finish the rest and the monster backside. It's not that hard. It's not that hard. So it looks it, but it's not. Just remember, start small. Start with the little parallel circuits, convert them into series, and then add them with other series to make series, and then you get another parallel, and then work your way out, or work your way in, and then work your way back out again. Kind of the way we just did. All right? We will have a quiz over this tomorrow, but it will look like that second, it'll be like 5 problems very similar to that second example that I did, with the 2, and then the 2. Okay? All right.